Hi, AP Calculus students. This is the last two problems from our 3.3 BC workout video, number 65 and 66. They are asking the same question. They give you a derivative graph on 65 and 66, and they're asking where is the actual function increasing, where is the function decreasing, where is its max, and where is its min. I might even put that F right here, right? Just so you know, right? So when we look here at number 66, where they ask where the max or min is for F, this is not the minimum of F. This is the minimum of the derivative graph, right? So be careful what you're looking for. And here's how I help you be careful with that, okay, is I have been provided with the derivative graph, and yet they're asking me questions about the actual function. So what I do is, rather than just start looking at the derivative graph and seeing if I can work it out, I translate what these statements mean to a derivative so I can look right here. And here's what I mean, is the derivative graph. They want to know where F is increasing. What does that mean as far as the derivative goes? That means the derivative is positive. The function values of the derivative is positive. So that's what I'm going to be looking for, is where the derivative is positive. And that is where the actual function is increasing, okay? Where is the function itself decreasing? As far as a derivative goes, that is where the derivative is recording negative values. Where does a function have a maximum? That would happen where the derivative is 0 or undefined. So I'll just put the critical point, because you know that's where the derivative is 0 or undefined. That's also where a minimum happens, is at a critical point. Right? That is where the derivative is equal to 0 or undefined. Okay. Now, a maximum occurs at a critical point where the derivative is positive and then the derivative is negative. Right? So positive on the left of the critical point, negative on the left of the critical point. Where is there a minimum? At a critical point where the derivative is negative on the left and positive on the right. Okay, so now that I've translated the function into the derivative, I can go to these places. So let's do that. First of all, F is increasing where the derivative is positive. Okay, that's where the derivative has positive y values. That is right here. Right? And I'm going to say where that happens. I'm telling the intervals where that happens. That happens where x is greater than 2. Right? So I can write that as an inequality, or I can write it as 2 to infinity. Where is F decreasing? That's where the derivative is recording negative values. That is right here in blue. Those are all negative y values. That happens to the left of 2. So that would be from negative infinity to 2. Or I could use inequalities. A maximum happens where there's a critical point where the derivative is 0 or undefined. Okay, well, for every x on this derivative graph, I see a y. I don't see anywhere where the derivative is undefined. Where is it equal to 0? That happens right here at x equals 2. Right there. So that's a critical point on the function. And we said that the derivative was negative before on the left and positive after. right? So this makes a minimum. There's a critical point where the derivative is 0, and the derivative is negative on the left and positive on the right. Negative on the left and positive on the right. This happens at x equals 2. There is no maximum, right? So notice this kind of makes sense too. What they're saying is there's a function that's increasing from 2 to 0, 2 to infinity. Let's actually start here. There's a function that's decreasing from negative infinity to 2, then it hits a minimum, negative infinity to 2, and then it starts increasing again. Notice the shape I just made is a parabola, which totally makes sense. If I had an original function that was a parabola with a degree of 2, its derivative by the power rule would be a line because it has a power of 1. Okay, let's go to number 66. Okay, this means not that we're drawing the actual function here, but the derivative graph is quadratic. This means to me that the original function must be cubic, because if I take the derivative by the power rule, I would get a quadratic, right? So let's just see once we get our answers if that happens. Okay, let's take a look. Where is the function increasing? That is where the derivative is positive. That is here, right? All these positive y values are being recorded for these x's, okay? So that is happening on this x interval from negative infinity to 0, right here. And then right here, right in this x interval, I'm naming the x's where that happens. That happens from 1 to infinity. Okay. Where's the function decreasing? That's where the derivative is negative. In other words, recording negative y values. That is right in between here, right? Between 0 and 1. Okay. Where are the maximums and minimums? That would occur at a critical point of the derivative where the derivative is undefined, but for every x I see a y on this derivative graph. Again, I don't think that the derivative is undefined anywhere. Where is the derivative equal to 0? Right here and right here at 0, 0 and 1, 0. Now let's check the sign of the derivative to the left and the right of those points. We already did. Positive, negative, and positive. So at this critical point right here, the derivative is positive on the left, negative on the right. That is a maximum. At this critical point where the derivative is 0, the derivative is negative on the left, positive on the right. That is a minimum. Okay, and you're done. But since you're stuck with me, let's go a little further. Don't shut off the tape. Oh, it's not taping. Don't shut off the video. Okay, there we go. Let's just talk about this real quick. That means, let's find out, let's go left to right. What's happening? The function is first increasing from negative infinity to 0 and hits a maximum, right? Negative infinity to 0 hits a maximum. Then it's decreasing between 0 and 1, right? And hits a minimum. And then from 1 to infinity, it's increasing. Notice I just went like this. That is a cubic. And it makes sense that its derivative would be quadratic. So I hope this helped you. Let me know if you have any more questions.